All right, so let's answer this question. It's coming from foundation physics. Of course, this is projectile motion. Now, the question says a stand flyer is moving at 50 meters per second parallel to the flat ground 100 meters below. So this is a flat ground, okay, and the stand is there, so it's moving in that direction, parallel. This direction is just the horizontal direction. Even this one is also just a flat ground, which is horizontal. I hope you now understand what's happening there. That means the stand is taking a horizontal motion. How large must the distance x from plane to target be if a sack or flour released from the plane is to strike the target? So if this is a flower, if this has to strike the target there, what should this distance be? Now this distance x, the one they're calling x, is just what we call the range. Alright, this distance is what we call the range. And the range is just distance. And how do we define distance? Now, remember, this is just a horizontal motion. And we know that distance is just equal to speed, which is velocity, in the same direction times what? Time. Now, to find x, that means we need to find the velocity. We also need to find what? Time. So according to the data given, Vx, remember they are saying it's parallel to the ground. So this is going like that. So that's a 15 meters per second that you are seeing there. Then time, we don't know. Even x, we don't know. So to find x, we need to find the time it will take for this to land at the target. Now, we are going to consider vertical motion. The reason is simple. Considering vertical motion because look at the distance. The distance is in the vertical direction. So let us find. So let me just write projectile here. So let us first write find the time. Now remember, if this has to come down, all right, if this has to come down there, it means it will move in the opposite direction of the distance. Do you agree? Remember that the distance is this. So for this to find itself on the target on the floor, it will move downwards but in the opposite direction. That means it will move in the negative direction of 100 meters. Clear, right? So using the vertical motion equation, which we know, all right, we are going to use the y direction, okay? This is just the displacement in the vertical axis, is multiplied by the velocity in the y multiplied by t, okay, plus half acceleration due to gravity, all right, okay, let's call it g, multiplied by time t. Now this gravity is actually in the y-axis as well. So solving for t, remember we are looking for t meters. So the displacement in the y, as long as the target hits here, it will be negative 100 and not 100 because to move in the opposite direction. And the initial velocity in the y, we don't have, we only have in the x. So here's 0 multiplied by t, which is 2 be 0, plus half acceleration due to gravity. Now remember, this is up, this is going up. Is it making sense? This is going what? Going up. So as long as it's going up, like it will move in the opposite direction of gravity, remember. So our gravity will be negative 8 meters per second. We know that, right? Let me just erase this meters there. Then time, it will be squared. So now, let us now work out for t. So we have negative 100 here equal to negative 4.9. Is it? So 9.8 Okay, so 9.8 divided by 2, you get that. So we have square here, but this negative will cancel each other, so we have t squared equal to, so we divide 100 by 4.9, then we square it, we square root it, so t is just 4.52 seconds. So this is the time of flight it will take from there to hit the target. Now that we know that the type of flight, and we said x is just like that, and the x velocity in the x-axis is actually 15 meters per second, and the time of flight in the x-axis is actually 4.52. So 4.52 we multiply by 15, we get our displacement to be 67.8 meters, like that. So thank you so much. Follow us for more NS videos on YouTube as well as on what, on Facebook.